In this video, I'm going to be demonstrating how you can use rational exponents to simplify higher order radicals. Now, just keep in mind that there are lots of ways to simplify your higher order radicals, and this is just one method. But if you like your laws of exponents and you don't mind them being rational exponents, then this method works actually rather nicely. We will be focusing on this basic principle right here. If I have some base raised to the m over n, that can be rewritten as the nth root of a raised to the m power, or the nth root of a to the m. Okay, so either way here, we're going to be implementing this rule backwards because we will be starting with our radicals and then attempting to simplify, but this works both ways. Alright, so for example, my first example right here, I've got the 10th root of x to the 5th. Alright, so if I rewrite it, if I start here and then I rewrite it so that I have a rational exponent, that means that the denominator of the fraction comes from the index right there, and then my numerator comes from my exponent right there. So then I would rewrite this as x to the 5 over 10. Alright, now dealing with your exponents, I now have 5/10 as an exponent right there. Well, I can take that fraction and reduce it to lowest terms. So then I would have an x to the 1/2. Alright, and now I have simplified it. That's about all I can do with that. So now I can turn this back into a radical because our whole point is we're trying to simplify these radicals. So then that means that this simplifies to the square root of x as a final answer there. Alright, let's take a look at this example over here. Alright, the first thing I would want to do is I would want to write it as a rational exponent. So this on the inside will be my base raised to that 1/8 power. So you might want to think of this one as having a little imaginary, say, 1 right there. So then the first thing I could do is x to the 4th y squared raised to the 1/8, with that indice there being that denominator of my fraction. Alright, now laws of exponents. You got to be really good at laws of exponents if you're going to use this method. Power raised to a power means that you're going to multiply. So I would need to multiply that 1/8 times each of those exponents there. So then I would have an x raised to the 4/8 and a y raised to the 2/8. Okay, now I probably need to take a look at these and see what I can do with them. Now, if I reduce them to lowest terms, this would go all the way down to a 1/2, and then this would go down to a 1/4. But if I do that, then my denominators are not the same. So I can reduce both of these fractions, but yet keep the denominators the same, because keeping in mind, I have to go back to a radical form if I'm trying to simplify this radical. So then it would make sense to then keep it as, like, say, x to the 2/4, keeping that denominator as a 4, and y to the 1/4. Okay, I've reduced those fractions, but yet kept each of them with the same denominator there. Alright, now, depending on how much work you want to show here, let's think of maybe undoing the power raised to a power rule. Alright, so that could be x squared y raised to the 1/4. All I did was take the denominator out of that, and then now I can easily see that that is the 4th root of an x squared y. Okay, a lot of steps, and maybe you could have went straight from here down to here, but if not, then throwing in that extra, pulling out that power raised to a power might be helpful on that one. Okay, say this third example here, the cube root of 27x to the 15th. Okay, on this one, I'm going to treat that coefficient by itself as a cube root because it's a nice cube root, comes out even, and just do the rule on my variable there. So the first thing I might want to do is go cube root of 27 times the cube root of x to the 15th. Alright, now because that is a perfect cube root, I can just work that one out as is. Cube root of 27 is 3. Okay, now when I do this one, I'm going to want to rewrite it as an x to the 15 over 3. Alright, remembering that that index right there is the denominator. 15 divided by 3 divides out evenly to a fifth. Alright, so this would be a 3x raised to the fifth power. Alright, and on my last example here, sometimes you do have nested radicals. So my suggestion here would be to work on the inside out. So deal with this square root of x first, and then deal with the cube root last. So I'm going to take just that inside and write it as a rational fraction, okay, rational exponent. So I'm going to have the cube root of an x to the 1/2. Okay, now I'm going to do it again. This would be my base, and if you need to see it, which you may or may not need to, alright, that all raised to the first power, making that x to the 1/2 my base. Now do the rule again. So then I would have an x raised to the 1/2 raised to the 1/3. Okay, again, power raised to a power. I've got to multiply those two. So 1/2 times 1/3 is going to give me an x to the 1/6. And then putting it back into radical form, I would have the 6th root of x. Alright, now this is showing a lot of work, alright, and it is only one way to simplify your higher order radicals, but if you're struggling with it, alright, sometimes this helps. Alright, after you get really good at it, there's going to be some shortcuts and little tricks that you can do to get from here to here really quickly without showing all of this work. But if you're having a hard time understanding it, you can apply these rational exponents and your laws of exponents to help you simplify those higher order radicals. Definitely thanks for watching. Really hope it helped you. If it did, go ahead and give me a thumbs up and be sure and share with your friends. Thanks.